Good morning and good afternoon, and welcome to this interview on Terragraph. This is part of a report on the Terragraph and the 60 gigahertz and the new opportunity that it offers to provide connectivity in a variety of environments using a wireless band, the 60 gigahertz, that has been not used as extensively as it could. It has a huge amount of potential. And today, as a part of the interviews that I'm doing on for the report, I have the pleasure to talk to Dave Sumi, the VP of Marketing at Siklu. And I've known Dave for very long time. We're going through a lot of excitement in wireless, and this is the last one. This is a really exciting topic. So I'm glad to talk to Dave and to hear what he is doing at Siklu. So Dave, welcome to this interview.
Thank you very much, Monica. We're happy to be here, and we're happy to share our views on Terragraph with the audience.
So before we get started, I know very well what you do, but maybe you can tell the audience a little bit about what is that you're doing at Siklu and what Siklu is doing in this area.
Sure, I'd be happy to. Siklu is very distinctly a millimeter wave company. That's all we do. We don't do microwave. We don't do sub-6 gigahertz. Siklu was founded with the vision of bringing cost-effective, high-capacity products, leveraging those 60 gigahertz bands and the 70 and 80. So the company has been focused on patents and development of RF technologies, again, all geared towards leveraging the amount of bandwidth you have in that 60 gig band, which is 14 gigahertz, and able to do it cost effectively in a way that can be used, profitably for businesses and operators.
Absolutely, and that's interesting because we've been working on what we now call millimeter wave. That was also called millimeter wave, but it was not a standard, a common topic in
Right.
A common name in the industry. So what is new? What is happening now that we are all so excited about?
There's a couple of things, and it's really a confluence of what I call the perfect storm of technology and market demand and need and companies being able to deliver. The need for speed and capacity has always been growing, has been growing for years and years. And recently, gigabits have now become, the table stakes speed for everybody. Everybody wants to deliver. The 5G new radio, the 3GPP, the cellular standards, they're all moving to the lower frequency millimeter wave bands, because if you want to provide a gigabit in wireless, you have to do it in millimeter wave, realistically. So what's happened is the demand has come about. So people now want a gigabit, they really need a gigabit. And so now as a wireless system, you need to go into the millimeter bands to do that. So what's happened in the last couple of years, and Siklu has been at the forefront of this, is cost reduction. It's great to have a technology that's going to do all these gigabits, but if you can't do it for a price that people can pay for and make money on, it's useless. In the last couple of years, there have been chipsets designed for 60 gigahertz. The first for the 802.11ad, which was an indoor wireless LAN standard, didn't do too well in its target market, but a number of companies, Siklu included, looked at this and said, hey, if I take this in the 60 gigahertz and I do outdoor wireless networks, I can really, in an unlicensed band, I can deliver the gigabits we're all talking about.
Absolutely, and yeah, and that it's free. I mean, not in every country, but in a lot of countries, it's freely available. There is a lot of bandwidth, so anybody can deploy it. You don't
That's
need
another, and that's another key enabler, Monica. And I think that people talk about the 5 gigahertz band and its interference and all the rest, but they forget there's been a tremendous amount of deployments in that band in the Wi-Fi industry and outside it. Because it's license exempt, anybody can use it. Now, 60 gigahertz is similar to that, but it doesn't suffer from the issue of congestion or interference. The very nature of the 60 gigahertz signals and the way that they're used in these products, you'll never saturate. You'll never really run into 60 gigahertz interference. And so while you have that 14 gigahertz in the US, and you're right, it's almost universal around the globe, you're going to be able to use that frequency without interference in the future.
Yeah, but what I still hear from people is that, yeah, that's all very good, but how about, you can't go very far, so what do we do with it?
Well, this is where I think 60 gigahertz and the Terragraph technology really shine together. The whole concept behind Terragraph is mesh topology. Mesh topologies, almost by definition, are very short links. So the 60 gigahertz products that we're coming out with, that you're going to see from other vendors this year, are all going to be able to go maybe a little less than 1,000 feet. But if you're doing a mesh network and you're doing a topology in an urban divide or anywhere in a city or even a suburb, 1,000 feet is plenty of range. If you look at it just from a typical single family home suburban area, most of those houses are well within 1,000 feet of each other. If you look in the cities, in the areas where a lot of this technology will be deployed on street furniture, that street furniture is well less than 1,000 feet. So yes, you're not necessarily going to use Terragraph or 60 gigahertz to go miles. That's really not its key sweet spot in an application perspective. But for anything 1,000 feet or less, this is tremendous boost of technology and another tool in operators' toolboxes.
Absolutely, and the limited range means better frequency reuse. So in a mesh environment, frequency reuse is critical.
Absolutely. One of the issues with mesh is they were kind of very polluty, if you will. But that actually, without getting too technical, there's, aside from the 60 gigahertz operation, which is key to give the capacity to the Terragraph systems, they've also done some other changes that are fundamentally different from what people may have been familiar with in the past mesh products. The Terragraph system used what's called a Tdma access technology, which means every device takes its turn to talk. And you can do it very cleanly and nobody's going to step on top of each other. So combined with the capacity that you get from the 60 gigahertz, this scheduled access that Terragraph provides means you now have mesh networks that can give you quality of service.
Absolutely. So, and I know you've been working on this for a while, but now we got to a point of having commercial.
Yes.
So
Yeah,
and that's a great thing because it's very exciting to talk about it, but at the end of the day, you want to see real life.
Exactly. I think Terragraph was founded, I may be off by a year, about 4 years ago. And there were some very early on proof of concept field trials in a couple places around the world. But it was not a whole lot. I will say for the past couple of years, most of the Terragraph discussion has been on those few trials, maybe a few others, and a lot of PowerPoint. But what's happened, there was a new chipset that's come out that operates in that 60 gigahertz, that provides that mesh QoS, that does beam steering, which makes installation a snap. Those chips were first released to vendors maybe about a year ago. And it's been my experience in the wireless industry, chip to product is about a year. So you'll find my Siklu and our competitors, and you'll find the entire Terragraph market. This is going to be the year of Terragraph. Everybody's announcing products because we all got the chips at the same time, and then we had to develop the systems on top. And so that's why you'll see a tremendous surge in Terragraph products this year.
Absolutely, and it's good to have a good ecosystem that can build on it, and so that we can all move forward. But what is it you guys have been announcing and doing specifically here?
So what Siklu, as I mentioned in the beginning, millimeter wave all the time. Nobody has more experience designing RF front ends or antennas. So what we differentiate ourselves in a couple of different ways. Everybody's using the same chip, so we're all going to get the same data rates. But everybody's doing their own radio, their own antenna, and we're doing our own versions. And we have patents and expertise, not in just the gain of the antenna, but the beam steering and how far you can beam steer. All of this gives us a physical layer differentiation. From another perspective, our Terragraph systems, the two that we've launched and announced so far, one is the mesh node itself, and the other is a terminal unit or a CPE that's going to go on a building or a house or wherever the access is to be given. But we're really focused on more than just the network elements, the boxes themselves. Siklu has a suite of software that we're very proud of that does automated network designs. If you're going to do a mesh network and you're going to have thousands of nodes, it's not possible to manually design where each node goes, which one is a distribution, where do my backhaul points go, where's my fiber point of presence. So automated tools such as that are something that we're adding to the Terragraph tool bag. We're also working on releasing a layer 2 SDN controller that will dynamically monitor these thousands and thousands of nodes for RF health. The system will automatically reroute around objections or link outages. So really, mesh networks, and one of the things that people forget is mesh networks are inherently very, very resilient. And I always remind people the best example of a resilient mesh network, the internet.
That is true. That is. But in order to get the resilience you need to have a good working mesh.
Yes.
Otherwise, the resilient is sort of only on paper. Well,
correct.
You know what I mean? And that I guess of course some people there is a concern, like is it going to be so complex that it really goes beyond me, especially if you're not a big service provider.
No, and that's absolutely, at Siklu, we look at the total cost of ownership, not just how much does that box cost, but how hard is it to install? What skill set do you require to be able to deploy these things? So we have done a lot of work in making these out of the box, bolt it to the wall and plug it in, and it will automatically scan the surrounding area, find the next node in that Terragraph network, connect to it. The network itself will give access, permissions. So really the deployment is as simple as it could be. Plug it in and walk away. So what we get with that is I don't need a truck roll. I don't need a guy who's an experienced RF installer. I can take that guy that puts a satellite TV on your house. That same skill set can deploy Terragraph, which allows it to scale.
Yeah, which is really important because even if money is not an issue, just the availability of people that actually have that expertise is often an issue. It's not like you find them everywhere. So
absolutely,
not the only.
No, I've seen great technology that just couldn't be deployed because the skill set to deploy it was so much. There weren't that many people in a country that could really put out millions and millions of nodes. And make no mistake, Terragraph's not talking about thousands or hundreds of thousands of nodes and devices. They're talking of millions and tens of millions of devices.
Yeah, absolutely. Yeah, and you need to have a good way to scale. So talking about scale, who do you think is going to buy your product, use it, and deploy it?
We see there's two primary use cases or applications that we see for Terragraph. One is the most obvious, which is internet access. We're gonna, you deploy this thing in an urban environment or a suburban environment, and connecting homes and families and businesses to these gigabit network. That's kind of the easy one to understand it, and that's kind of the classic wireless application. The other area that we see quite a bit of traction for Terragraph will be in smart cities. Smart cities used to be, focused on sensors and water and electric, but now cities are actually adding broadband applications such as public Wi-Fi is coming back, video surveillance is coming back, traffic control and management is becoming a big deal. So these applications are all driving, hundreds of megabits or gigabits of capacity needs. So we see Terragraph in the smart city as being ideal. We're working with a number of partners, and I think you'll see others as well, that are looking to integrate Terragraph modules into street furniture. That way, your local light pole, which already has power, now has connectivity.
Yeah, absolutely. And you can combine different applications. And I think you bring up an important use case. I mean, clearly the broadband connectivity to the home, we understand it better.
Right.
It's been there for quite some time. But for smart cities and in general for IoT type of applications, there is often the assumption that they're all kind of require low bandwidth, think of sensors, right, meters, but that's really a small, I mean, especially if you look at it from the demand point of view, it's just a small part. There's an increasingly large amount of applications that, well, backhaul being obviously one of them, but all the applications like, surveillance, a lot of safety applications,
yes,
security applications do need to have a lot of bandwidth.
And I think you actually touch on another point that's a feature of Terragraph, which is low latency. So, one of the use cases that people are talking about is 5G small cell backhaul using Terragraph. So, and you can only do that. I mean, the 5G new radio standard is trying to keep latencies in single digits. Terragraph systems will do better than that. So I think that latency support, that other feature, not just capacity, but that latency number allows us to address video security, allows us to do these things that are latency sensitive.
Yeah, absolutely. Because because even if you use it as a backhaul, it doesn't matter if the access has low latency, you need to have also the backhaul.
Correct.
Low latency. Both of them need to have low latency. So in this case, do you see the cities themselves taking the ownership of the network? How's the business model work?
We're seeing a couple of different models, and this is still kind of shaking out because the cities have an opportunity to run and own this network and then lease it to others and make some money, but that's generally not in their DNA. So we're seeing the cities and partners, we're seeing the public-private partnership is still kind of feeling itself out. But what we've seen in some cities, the city will go to an operator and say, I'll give you access to my easements. You do this and give me low internet rate to my poor or underserved urban housing, and then you can cover the whole city and make money. So that's one of the ways. The city grants what it has for free, which is easements and access to its poles, et cetera. And then the operator comes in and does the network. There are other models that are still shaking out. I think ideally, if I was going to recommend to a city, I'd say if you have the temperament, do it yourself. But if you don't, you can find someone to partner with who will, for your easements and access, maybe give your city network for free.
Yeah. But I think that one thing that I think it's interesting is that what we're seeing is that the cities or enterprises, whoever, they want to have some level of control. So
Yes.
they're not just, they could go to a mobile operator and lease capacity. That doesn't seem to be much of a model at this point. It's more like we might not run the network, but we want to know what's going on. We want to have some level of control. And that unlicensed spectrum allows the cities to do that.
Well, you're exactly right. And while technically the cellular networks are capable of supporting some of these devices, you're talking about, let's just say an average 11 AC access point is going to drive 1 to 2 gigabits per second. Now you multiply that up by all the seconds in a month, and you can get an idea of how much you're going to have to pay your local mobile operator for that device. It's substantial. So, if you want to do this equipment wirelessly, the 60 gigahertz is the way to go. And with the Terragraph systems that are coming out, again, the cities don't have wireless experts. They don't have guys that are used to doing this. They do have departments that know how to take care of their streetlights. They do have departments that take care of their sanitation. They have skilled laborers, and that's all they need to deploy Terragraph.
And they have a lot of assets.
And they have a lot of physical assets, which is really a leverage arm for the cities.
Yeah, I once was talking to somebody say, the wireless business model is half wireless technology and half real estate.
Yes.
And I think that's really what it is, right? Okay, so now we are ready to go, ready for prime time, but it's still something that it's being evolving. So
the product,
can you talk about what is that you are doing at Siklu, especially in terms of the evolution of the product?
Sure.
Or in general?
So we have our existing 2 units that we've announced in December, our Hush mesh node, which is what they call the distribution node. We also have our terminal unit that goes on buildings or houses that connects people at the end of a mesh network. Over the course of 2021, we'll be focused both on new software packages, new features and functionality, but we'll also be doing new variations and additional versions of our terminal unit. One box does not fit all. We may have one that has a built-in switch. That way you could easily have 4 or 5 different customers plug into it. We're also certainly going to be looking at a longer range terminal unit. We can get these things to go much further than 1,000 feet. It takes a little bit of size and a little bit of antenna, but you can, and there are applications and instances where people need to go further. But one of the other ones that we'll do is, I think everybody's familiar with our compact TU that we did for our existing product line, the multi-haul, which is just barely bigger than my phone. So we'll almost certainly in 2021 be releasing a Terragraph version of this. And if you see this and you put this on the side of a house, now this is in Siklu green, but we've made this so it's paintable and you can order it in any color. At that point, you've really become very aesthetically pleasing for the homeowners association or the cities or even the residents themselves who don't want a big ugly box on their house.
Yeah, I think this is a very underappreciated thing of, the ugliness of the telecoms, or the community, wireless or wireline. And I
Yeah,
think we can do better. So I think that that's a great thing to have something that is,
we really try to look at these things as complete systems. And I know the phrase solutions is definitely overused, but we take a completely holistic approach to our products. As I mentioned, not just what can it do technically, but how easy is it to install? How easy is it to manage? What do you do to use it? What are the aesthetics? So we try, we've been doing this for a while. And we've got a lot of experience in these use cases and a lot of feedback from a lot of customers that guide us in where we're going with our roadmap.
Yeah, absolutely. We love to talk about the technology, but for the end user, it's really, does it do what it needs to do for me without creating too much trouble, too much ugliness, or too much whatever?
Exactly. I mean,
We don't.
even though the satellite dishes have gotten a lot smaller, there are many homeowners associations that won't allow them on the roof.
Yeah, absolutely.
We've never had anybody object to this little guy.
Absolutely. You just need to have wireless with power now, and then
Strictly wireless.
So, okay, so let's just look at, what's going to happen in the next 5 years. So this is the year of Terragraph. So how do you see it working in terms of who's going to go first? What's going to happen? What are the major developments as we move forward?
Well, I think now as it's being introduced, as with all wireless network equipments, in my experience, there's always a rollout phase. So the products are now available. People are going to do proof of concept. They're going to get some. They're going to put it on their bench. They're going to get some more. They're going to try it outside in a small environment for a couple of months, and then they'll scale it and they'll try it bigger. So I think it'll be the second half of the year that you'll see mass volumes of Terragraph equipment being produced and entered into the market. We're all kind of in the trial stage. There's a tremendous demand and interest in Terragraph from our customer base. I mean, we're having trouble keeping up with them. That's all anybody seems to want to talk about, which is good. So we're busy seeding the market with as many trials as we can, and we expect those trials to grow into real networks in the second half of the year.
Absolutely. So that's going to be really exciting, and maybe we should touch base a year from now to see what we have learned, because there's always so much to learn.
Yes.
We were not expecting, and that's the fun. That's what prevents us from getting bored at any point in time.
It is interesting. I think, wireless has been around a long time, but it's always exciting. And I just think that the 60 gigahertz, the demand for gigabits, the Terragraph mesh, all coming together is just a beautiful conflict, the perfect storm.
It is, and it's all coming. We needed a lot. I mean, 60 gigahertz has been around forever.
A long time.
But it's only now that we have the confluence of things coming together. And if they don't come together, there is an opportunity that you can really use. So.
And then, one more thing, another element of the Terragraph that we definitely need to mention, which is the whole idea you do an industry standard such as this is so you can generate volume manufacturing. First of all, you need a chip. You cannot do customer equipment at a price that's going to be acceptable to the market without having an ASIC in there. So you're not going to get companies to go design an ASIC unless they believe there's tens of millions of devices in the market. So Terragraph, having the chip, the volume manufacturing is going to bring these products prices down. And that's what's going to make the business case for the operator. Because it all comes back to the point of the operator, he's going to get $50 a month from that resident for a gigabit. That's all he's going to get. Can you give him a business case that has $50 a month and a 2-year ROI? That's the goal.
Yeah, and that's been a very old-fashioned principle, but it's never going to go away. It's like one of the certainties in life, right?
Yes, that has not changed. And the only thing that's changed in my years in wireless is that it used to be $50. It was $50 for a megabit. Then it was 10 megabits. Then it was 100. Now it's a gig.
But you still need to make money, and you still need to keep within the constraints of what it is that you're working with.
Exactly.
So
it has to be a viable business case.
Okay, Dave, it was great talking to you, and look forward to the next one.
Thank you very much, Monica.
So this is Monica Paolini from Senza Fili, and I've been talking to Dave Sumi at Siklu. And this is part of a report on Terragraph and the new opportunities in the 60 gigahertz. Thank you all for listening and watching.